This presentation will be mixed between Spanish and English. I hope my colleague Forbes, Deborah, and David speak in English.
Welcome to the 32nd Aapresid Congress, first time in Buenos Aires, so it's a huge event now. And well, David, sorry, but maybe you have some news about that, what I'm going to tell, but when I was a young professional in the 90s, I was looking for anything related to the news. It was a huge development at that moment called no-till, and I was searching for everything related to that. So I was told that in my land, not in Italy, in Tennessee, in the United States, there was a big and a huge field day with a big attendance, more than 10,000 people, and a lot of machinery dedicated to no-till. That was what I was looking for at that moment. So I mixed some tourism with that, and I convinced my wife to go there. So I visited Graceland and Sun Studios and Jack Daniel's distillery in that moment, and it was nice too, but the field day was a shocking moment for my career. I think you must be proud of that, I think. So at that moment, the technology transfer was mouth-to-mouth. So bringing all the stakeholders together was the clever thing to do. And here in Argentina, we were doing the same in Aapresid. We will have field days called Un Productor en Acción, a farmer show, one farmer showing. And it was the most similar thing I ever seen what Aapresid was doing. So believe me that it's an honor to have you here again, and because in some part you plant that seed. Because my participation in this institution began with that moment, and a lot of transfer, because I'm not a spy, I go there just for information, and when I came back, some ideas I bring back here. So you're more than welcome. You are part of this. So please feel you at home. No problem. Forbes, you're the first.
Thank you very much. Good morning, everyone. My name is Forbes Walker. I'm from the University of Tennessee. I'm a soil scientist. And today I'm going to talk about how we conduct agricultural research and extension activities in Tennessee. This is very similar to what all the other states do. So while I'm talking about Tennessee, there's a similar infrastructure in place in all the other universities and the other states in the United States. Before I start, I'll just talk a little bit about Tennessee climate and crops. So we're in the yellow state there in the southeastern United States. It's humid and temperate climate. We have about 1,200 millimeters of rain, so similar to the rainfall here. And we have, around 200 frost-free days a year. So we get frosts, but not very common. Because we're in the northern hemisphere, we are planting our crops in April to June, and then we harvest September to November. Our major crops, very similar to the crops we see in this part of Argentina. We grow soybeans, we grow maize, we grow wheat, and we grow cotton as well. So the University of Tennessee, we work for the Institute of Agriculture. The Institute of Agriculture, if we go back to the history after the Civil War in the United States, there was an act that was passed by Congress that basically said each state will have a land-grant university. The land-grant university's responsibilities, starting back in the 1860s, was to do agricultural research, and then later on in the 1914 Act, they established an extension service, and the idea is our university conducts agricultural research, and we get the information out to farmers. There's a map there of our state there. We're a very long state east to west, but across the state we have about 10 research stations. capturing all the different types of agriculture that are conducted across the state. The state is divided into 95 counties, and in each county we have an extension office. And in those extension offices, we usually have people that are talking about agriculture to the farmers in the area, as well as some people involved in youth development and some people involved in family and consumer sciences. This is just a map where the different research stations are across Tennessee. The one that was being referred to earlier on Milan is one of the ones in the western part of the state. But we do research in crops, we do research in livestock, we do research in urban areas. The research, we get both applied research as well as basic research. I'm an extension specialist and I do a lot of applied research. A lot of my colleagues on the basic side of things will actually look to see the practices that we're doing. What are we doing in terms of soil health? What are we doing in terms of soil biology? And more these days, what are we doing in terms of climate change adaptation, mitigation of greenhouse gases, carbon dioxide, nitrous oxide? In each of our 95 counties, we have these extension agents. They're very good at lots of things. But when they need additional assistance, they will talk to us and we will work directly with farmers. The university, we have different departments. This is typical of many agricultural institutes across the United States. So we have, people working in economics, animal science. I'm in the biosystems engineering and soil science department. We have entomology and plant pathology, food science, plant science, and forestry, wildlife, and fisheries. So no-till research began back in the 1970s, and really what it was farmers came to us and said, we've got too much soil erosion, we've got to do something different. So starting in the 70s, we started working, primarily the extension people, but some of the research people, we started working in West Tennessee, which is where most of our crops are grown. The research station at Milan, in 1983 went 100% no-till. It has been 100% no-till since 1983. Attendance at some of the early field days was very, very high. You can see in 1995, over 11,000 people actually attended the field day. 2 weeks ago, we had our last field day. We had 1,257 people, so it's lower attendance, but still quite a lot of interest in the area. The other thing I will say is that we're very proud to say that in Tennessee, we have the highest rate of no-till adoption in the United States at 93%, so a great story there. I'm just going to give a few examples of some of the things that we talked about 2 weeks ago at our last field day. You can see these are the types of tours that we put on. So we had talks on no-till production in corn, cotton, and soybean systems. A lot of talk about pesticide updates. What are the most current pesticides? And what new technologies are coming, so you can see some of the talks there. A lot of talk about crop water management, as well as ag water treatments. I'm involved a lot of cover crop work, so we had a lot of work talking about, where are we with cover crop adoption, what kind of cover crops are we growing, how do we grow them, and how are they impacting our yields, how are they impacting our soil health, what impacts are they for the future. And then some other talks on, hemp production. This is a fiber that we're starting to grow a fibrous crop we're starting to grow in Tennessee, and updates on the soil fertility management and soil-borne diseases. So in total, we had about 16 of these tours, 3 to 4 talks per tour. So almost 50 talks was held at this field day, which we had a couple of weeks ago. Give you examples of some of the things that we covered at this field day. This is work from some of my colleagues there, Dr. Sindhu Jagadama and Dr. Rachel Wolliver. They've been looking at the impact of different types of cover crops, whether it be single species cover crops, or double species, a legume and a grass, or multi-species. What impacts do these cover crops have on crop yields and on soil health? And you can see the types of information they presented. That column on the far right is the multi-species mix. We're really promoting some of these things, and for the first time we're actually demonstrating that these things have a great impact on improving yields in our different crop rotations, as well as improving the soil health. Another colleague of mine, Dr. Ader, he does a lot of work on soil fertility issues. This is the talk he gave on some recent work that's been conducted on nitrogen management. How do we improve our nitrogen use efficiency? How do we reduce some of the nitrous oxide emissions? And you can see he's done some work on different types of fertilizers. Our common nitrogen fertilizer is urea. We also have urea ammonium nitrate. Done a lot of work with nitrogen stabilizers, urease inhibitors, to look at can we improve the uptake of the nitrogen. And so these are some of the rates that, some of the recommendations he has. Interesting to see that our rate, for nitrogen use, 180 pounds per acre, 180 kilograms per hectare is very similar to what you are doing here in Argentina. And we like to recommend splitting the applications, a third at planting and 2/3 later on. This is another talk. This is one of our economists, Dr. Aaron Smith, talking about sustainable aviation fuel. This is an area that's getting a lot of interest. I'll be talking later on this afternoon about sustainable aviation fuel. But this is some of the early modeling work we've done. We typically don't have the infrastructure to grow oilseed crops, which is what we're talking about in the future. We'll talk about that later. But this particular presentation suggested that, yes, this is going to be the future of our cover crops. We're going to be changing from a cover crop, cash crop system to a double cropping system with oilseed crops and then the cash crop. Some more data from some of my colleagues, Doctors Sean Schaefer, Sindhu Jagadama, Deb Saha. They look very much at what's going on in the soil in terms of the soil biology, shifts in the patterns, and we do see shifts in the biology depending on whether we're tilling or whether we're using cover crops. Also some early work on what goes on with things like soil viruses. This is a new area of research for us. And the graphs on the far right show the impact of these different practices on greenhouse gas emissions and what can we do to improve the future of that. So I will also mention that recently, last year, we've had a visit from Marcelo Torres, president of Aapresid. Here's Marcelo with Dr. Blake Brown, who runs our research station at Milan. And with that, I will conclude my brief talk. And we've got a short video here, messages from farmers from Tennessee, so enjoy.
My generation is able to farm today because of no-till farming. Hi, I'm Alan Meadows. I serve on the board of directors with the American Soybean Association. As you know, every day on the farm, there's a different challenge that arises. Over the years, UT has always been there to help us through those and find solutions. No-till has allowed us to do things that we never thought possible. It's allowed us to preserve the soil. It's allowed us to be more productive. It's allowed us to do many different things that I would tell you, if there's anything that has transformed farming here in West Tennessee anymore, I don't think that there would be anything any more than no-till has done. When we first adapted no-till practices here on our farm, it was strictly done for soil conservation purposes. We felt like that we were losing too much soil over the years to erosion, that we needed to make a change. And what we've come to realize over the years is that while we did help with soil erosion, we also helped in many other areas, and no-till has helped to make us more sustainable and conserve those natural resources that are so valuable. No-till farming is the foundation of sustainability.
The entire world is depending upon us not only for supply of food, but how we supply it. Hola, Argentina. Hi, I'm Johnny Dodson. I am the former president of the American Soybean Association, and I have served as an officer on the United Soybean Board. Well, all farmers, wherever you are in the world, face their own unique challenges. But one of the challenges that we all face is issues with production. And we have a unique opportunity here to increase our production wherever we are in the globe. The University of Tennessee has been a very, very active partner in helping us learn how to no-till our ground. So soil health is a key for our production, our increase in production, healthier soils, and cleaner rivers and streams. Since the beginning of time, land-granting universities have been primarily responsible for developing best management practices, tools for farmers to use in the production of crops. That tradition lives on today.
We are all in this together. We have a common bond, and that's agriculture. And we need each other. Hola, Argentina. I'm Eric Maupin, and I currently serve on the United Soybean Board. No-till is evolving. It's not something that started 40 years ago, and those practices 40 years ago are the same that we're using today. No-till is such a generic term. We've got to do the research and work together to try to find those best management practices to make us sustainable in the future. So let's join hands. Anything that we can do here in the States and Tennessee to join with you and help us both be more profitable and produce more food for this world. We have a huge challenge facing us. It may not seem like it today, but we have a lot of hungry people around the world to feed. We are not competitors. We are united together as brothers and sisters in agriculture. And so I welcome you to come to Tennessee anytime you would like. I hope that I have the opportunity to go back to your country, and we will share information and work together to feed the world.
Thank you very much, and please say thank you to the message. I truly believe, and I know that it's something like a brotherhood of farmers, every international brotherhood of farmers. So, please thank to our partners. David, please.
Buenos días. Muchas gracias por recibirnos.
Good morning. Thank you very much for receiving. My Spanish is not my first language, but I will use Spanish for my presentation. I like this video because it said that we are brothers and sisters in agriculture. We are not competing one with the other. That's why we're here to discuss and to learn one from the other. I am going to present something about the circular bioeconomy. I'm a professor of sustainable agriculture at the University of Tennessee. All three of us work there. Tennessee, like Forbes said, is there. We have a state, and our economy is based on agriculture. I will start with an example. I do not work in agriculture in Tennessee. I work elsewhere in Africa and Asia because we have similar problems. We're losing our soils at a worldwide level. This is a big problem because there's more people and more demand placed on agriculture. I will show you now an example from Cambodia, a small country in Asia, where people have always had agriculture on their farms, but also they have these small mountains made of calcium carbonate and limestone. And in these mountains, we have bats living there. And these bats every day leave their cave to eat bugs and then go back to their caves, and they deposit their feces there. And people go there and look for it. They pick it up, they put it in bags. And why? If I go there, it's not a nice place to be. It's very dirty and smelly. But they go there because this manure has a very, very high value for their farms, for their rice and their vegetables. And so they've known that this circular system exists, that it's super important, that nutrients are highly valuable. So we've had to go there to study many details of this system because the government is removing these limestone mountains to sell as cement. So they're breaking this circular cycle. We've always known about this we've always known about these changes in our system. In the 1800s in Europe, they were already discussing this, that they were losing nutrients in their soil because they went to the cities and never went back to the countryside. Actually, people had a war in the islands near Peru where there was a lot of guano from birds. They actually had a shit war, literally. And it was incredible to think of that. But it was so important to have those nutrients that they were willing to fight for them and kill and died for them. Now we found the way to create nitrogen from air. Ivory Bosch and these chemists created a process that helps us have nitrogen and other nutrients on our farms. The problem is that we use quite a bit, and to create this nitrogen, we need a lot of energy. And we lose a lot of these nutrients with rain and with the effects of the environment. And so this is not a sustainable situation. So this is something that we are learning nowadays, that there's a negative effect on this. So we're learning to do this more sustainably. We're making progress, but it's still very difficult. One of the reasons is that we must continue with the system of having more people and more people living in cities. That is something that is happening globally. And when we talk about this at universities and elsewhere, they talk about value chains. And we think of these chains as a line, but it's not a line. It's more circular than linear. We have to change our mentality. So this concept of bioeconomy, how can we base our economies not on oil, not on petroleum, but on biology, on the nature of microorganisms and everything that we have to develop an economy based on biology, and not think of something linear, but rather circular. So nowadays, people are talking about the circular economy, and this is a very important concept. One of the reasons is that we always talk about waste. We talk about loss, but we shouldn't think that waste exists. Waste does not really exist. These are co-products. These are products that also have value. In the United States, unfortunately, we lose a lot of our food. We waste, we throw it in the garbage, a lot of that food, but that food could be useful for many, many things. So it's a matter of changing our mindset. But it's also a goal of the United Nations with Sustainable Development Goals, which are part of these, part of what humanity is seeking. All countries must try to achieve these goals. This means that we need to change the way we do things and think of things. And people like Aapresid, institutions like Aapresid, know that the system needs to change. And I think we're all here to learn more from that. So thinking about plastic, about energy, about oils or biofuels, and that kind of thing. Like Forbes said, there's an idea that can become very important, which is biofuels for the aviation industry. We flew here, and we use a lot of liters of biofuels in our industries. But how could we do this using not oil, but the biology? Just to move on this quickly, I work in Africa a lot, and they have very small lands. They have less than 1 hectare per family. It's very difficult to make a living, and we're always trying to improve their system, but making small changes, practical changes. On the left, you see an example in Rwanda where we help them, have this poultry farming to eat. These are projects because they know how to grow poultry, but what they said is that it was very important for them that the manure, the feces of these birds have a very high value. So we've never had to buy fertilizer. And now we throw it on our potatoes, on our wheat, and we're increasing our harvest, almost double in terms of potatoes. On the right, this is in Uganda, where there's a lot of peanut production. But the waste of the peanut, for example, the shell, nothing is done with that shell, but this shell has a lot of value. So we need to find ways to harvest this value and to make the system more circular. This is not easy. So when we talk about these things, we wonder, what are the challenges to implement this at a small scale? What are the options? We can think of solar panels. We can consider harvesting water. How can we do biochar with this waste, biofertilizers? It is not easy, and sometimes the investment is quite steep, but we must think of this and how to do it at a smaller scale. Many opportunities exist, and these opportunities include biogas, biofertilizers, biochar. All of these things are things that we're learning through research. We know that there's a benefit in doing these things, and we must think of it at all scales, thinking of how we can all include these principles in our production. But the issue does not only involve farmers. I live on a farm, and I think of these things all the time. How can I improve my systems, etc.? But there's a lot of involvement that is needed from the governments, from the institutions, from research that we carry out at institutions, the social and political and economic aspects. We need to think and change these systems not only at the farmer level. Of course, that there are people on the farm that need to change, but we must all consider these things. We are teaching little kids about these circular principles. Are politicians speaking about this, or are they only speaking about scaling up their economy? How do we want to do this scale up? It has to do with changing our mindset. That is why I'm here, to learn from you and to share what we are doing as well. And I definitely thank you for your attention.
Okay. Hola. Como dijo Dave.
Thank you very much for welcoming us here. We're very happy to be here. I will give my presentation in Spanish. I apologize because maybe a couple of words will not come out exactly as wanted, but I'm also at the University of Tennessee at the School of Engineering, and I work in a research center that uses computational science. And I will be presenting to you today how at the University of Tennessee we use the high-performance computation systems to apply in agriculture, as well as sustainability and environmental remediation. So let me start by discussing what computational science is if you haven't used it yet. What high-performance computation is and how that leads us to artificial intelligence and applications that we implement at the university. So computational sciences are a multidisciplinary field of study that uses mathematical models to do simulations with a computer in order to analyze data, in order to try to find solutions to the different problems without having to do everything at the lab. This may be because maybe experimentation adds contamination to the environment, or because it cannot be quickly repeated. Computational sciences try to connect theoretical and empirical research And we develop models, or we use existing models that we know already work well. An important application of computational sciences is that they can accelerate discovery and solutions and can be applied in several areas, including health, engineering, environmental sciences, the climate, etc. When we have state-of-the-art or accurate predictions for climate, for example, or whether we will have a storm or hurricanes, etc., everything comes from being able to analyze a lot of data very quickly and make predictions. It's the same principle, but in this case applied as Forbes and David already explained. This is to show just a snapshot of how computational sciences, especially high-performance computing, HPC, you will see it in my presentation as HPC, how it grew from the 90s until now. In this drawing, you can see the y-axis, where we measure the performance of computing. And the curve goes up in 2022 because that's when we started the exascale area in computing. That's where we are now. One of the things that enabled this growth in high-performance computing is to use artificial intelligence. You may have heard of machine learning models. All of that is within the umbrella of artificial intelligence. For you to get a grasp of, or some perspective of what the hexascale, where we are right now, means, we have the quickest and biggest computers that we've ever had in our area of research. And this one in particular, called Frontier, is also in Tennessee in a national lab. And so what is a flop? Flops indicate performance of a computer. So a computer that can do 10 at the 18th or 1 quintillion operations per second, that is an exascale computer. If we know that there's our 31 million seconds in a year, if you did 1 operation per second, you would have 31 million operations per year. To do what an exascale computer does, it would take you more than 30 trillion years to do what one computer does in 1 second. So that's the scale that we're talking about, yes, and how this can be accelerated. But not everything is perfect with this. In this example, you can see how everything can be quicker, but not everything can be done more quickly. It depends on how we create the software and how we create the applications to be able to use this type of computer for the problems that we need to solve. In our center, specifically in my research group, we are currently in the intersection of applying HPC or high-performance computing for the environment, energy, and national security as well. This drawing here shows the different areas that are involved in our projects and which involve developments of software, chemistry, mathematics, engineering, economics, and also applications on critical minerals and radiochemistry as well. Some of the specific projects that I wanted to share with all of you for you to get an idea and also for you to think about this. If you work on something that is related to this, maybe we can work together, so do let us know. For example, we have a project that where we apply artificial intelligence for environmental remediation. What we do in this case is to use AI to try to look for better ways to eliminate anthropogenic contaminants. These contaminants have been introduced into the environment by humans. Another project that we have where we use AI in order to assess and design morphology for biochar. Biochar was already mentioned by David, with the goal of using biochar as a fertilizer on soils and also for carbon capturing. We also use artificial intelligence to manufacture products that involve critical minerals. In Tennessee, we have coal and ashes that are produced in the coal industry. Sorry. The thing is that these ashes contain critical minerals that we can apply on other uses. And at the same time, these are toxic for the environment. So we need to find another use for ashes. When we do this, it helps us eliminate contaminants in the environment while helping us find other purposes to use them, related to what David said in terms of the circular economy. Another project that we have that is quite large is a consortium for nuclear forensics. You may wonder what nuclear forensics have to do with this, but there is a side which has to do with radiochemical application that has to do with the environment and with contamination. So we use AI and high-performance computing to develop chemical processes that are more beneficial for the environment and which do not contaminate. And with this, I will close. I hope that with this, you've gotten an idea about what we're doing in Tennessee with high-performance computing applied to artificial intelligence and to these different projects. I am honest when I say that if there's anything here that you can relate to, please contact us, because with AI, we have very effective models. But for them to be good, we need data. We need large sets of data, and we need data that has been built in a way that does not introduce biases, so that the results are reliable. And with that, I thank you for your attention and for your invitation. Thank you very much. We'll probably answer in questions.
Gracias, Deborah. Creo que van a poner en la pantalla.
I think that on the screen, you will see a phone number to send questions via WhatsApp, but I already have some that I've received for Forbes.
We have 96 extension offices in all the counties of Tennessee. How is that funded? How you found them?
So the funding for the extension offices in Tennessee, so part of our funding comes from federal sources, part of our funding comes from the state of Tennessee, and part of our funding actually comes from the individual counties themselves. So because the extension is very much part of the community, and the community recognize the benefits of having a good extension office, they actually will support part of the activities of the extension from the county funds.
So there's no national extension agencies, only they fund the universities to do that.
Can we hear? Oh. So there is some funding coming from federal sources, but it's becoming less and less, and more it's being relied on from the states as well as from the local communities.
Okay. And David, you said that I have maybe un solo tema. ¿Cómo?
Maybe I have just one topic. How small holders, in order to help them get into the circular economy, they need some kind of investment. For example, how to do a biodigester and also pay for it.
There is some funding from the national or the local governments. How do you imagine that?
Bueno, en nuestro
We have funds to help smallholders in the States. But the problem is that there are other continents or areas that have no funds, not even to eat. So investment is not possible. There are different sources, but the problem is not always funds. I'm also talking with the youth, young producers, young farmers, and sometimes it's a question of knowledge, having access to information, and that is changing. Wherever I go in the world, everyone has their smartphones, and they are connected. They do not have electricity at home, but at least they have a smartphone. And that's really valuable, to have access to information. They rather have access to information than water and light at home and electricity. And the other important thing is statistics. Sometimes we think how to change the system, but it has to do with transport logistics, and that is a larger investment. We have to think more not only on the theory, but how to apply it, how we can make it happen, to make it applicable in the field. Thank you. Deborah, let me ask you a question. Do you think...
And I need a supercomputer like yours. Is something like there is a waiting list, you have to, is available for everybody in the world, or just for you in the universities?
Okay, so hay distintos recursos.
There are different resources, there are different levels. Let's start by the smallest unit. A professor in a lab has a computer or a cluster of computers. Universities have resources. National labs have resources. That resource I showed there is the largest one in the country. The access levels vary, depends on it, but I wouldn't focus so much on the access to this type of resources, because that is needed when it's very large, huge data. The biggest difficulty lies in turning the data you collect in the farms and the fields so that they can be parametricized and classified so that they do not introduce any kind of bias, so it's reliable. That is the part that requires the most work. Once this is developed, we have to train algorithms. With AI, it's not that complicated. I wouldn't focus so much on resources. I would focus more on developing or building the applications that are going to train the algorithms. Thank you. Wonderful. I don't know if we have more time. If there is a question from the audience, we will close with that question. Perhaps this question can be asked to the three of you.
About the soil health today in Tennessee, which is the main thing that they are looking for about soil health? No?
For us in Tennessee, the big thing, as with here in Argentina, is increasing the organic matter and the carbon in the soil. If we can increase that, then we drive a lot of the microbial processes in the soil. So combination of no-till systems as well as cover cropping and other good soil practices. You know, we started off doing these things for soil erosion, then it was for water quality, then it was for soil health, now it's for climate change adaptation. It's all the same practices basically. So no-till is the foundation of a good agricultural system, and in combination with some of these other practices, cover crops, and the future may be these relay cropping with oilseed crops for the aviation industry.
Yo diría que en África, por ejemplo, ya están un poco más.
In Africa, they are more focused on preserving their soils. They are losing soils to erosion. And in Asia, we see that their rice system, we do tillage, and we are losing capture, and they are losing soil. So it's very difficult to change their mindset, their system. We they think they cannot grow without tillage, but we do know it is possible. So it's a question of changing practices.
Muy bueno, muchas gracias. De vuelta, very thankful for fellow there, very nice. And I keep one concept that they bring us, is that no-till is not a generic concept nowadays. So thank you again, and you are very welcome for ever. Thank you very much.
Fuerte el aplauso para esta primera charla.